Some sulfur chemistry is described here using the ChemBlocks models with the sulfur model and several other ChemBlocks models. Sulfur dioxide is a molecule formed, among other places, in the smokestacks of coal-burning plants. The oxygen gas reacts with the sulfur, oxidizing the sulfur into the +4 oxidation state. The sulfur's non-bonded paired spin electrons in its valence shell keep the molecule in a bent shape. When a water molecule reacts with sulfur dioxide in the atmosphere, it creates sulfurous acid. This is the acid that had wreaked havoc in the environment before it was removed from coal-burning emissions. Here you can see it's in the +4 oxidation state. The tautomer of the bisulfite, with the proton still attached, shows 5 positive oxidating oxygen bonds and 1 minus reducing hydrogen bond, giving an overall oxidation state of +4 on the sulfur. The conjugate base of bisulfite is persistent in the environment. This is the conjugate base of bisulfite. The anion is formed on the oxygen, can migrate between the other oxygens. And the hydrogen can protonize onto any one of these anionic oxygens in the tautomer state, which gives 6 separate anionic states for the bisulfite and the bisulfite tautomer. This is not unlike other strong acid bases like iodic acid. In each state, sulfur stays in the +4 oxidation state. Adding a water molecule to the -2 sulfite ion can produce sulfuric acid. The 6 oxygen bonds oxidize the sulfur into its +6 oxidation state. Protonization of these hydrogens can show the anionic base of sulfuric acid, which is not demonstrated here. Sulfur hydride is similar in shape and constitution to the water molecule. The hydrogens are bent from the 2 non-bonded paired spin electrons in the sulfur valence shell, creating a repulsion with the hydrogen bonds. The +1 oxidation state of each hydrogen creates the -2 oxidation state on the sulfur. Sulfur dichloride puts sulfur in its +2 oxidation state. The chlorine oxidizes the electrons, which of course is another example of chlorine being a strong oxidizer. Other sulfur molecules demonstrated using the ChemBlocks models can be shown, included these triflate catalyst anions, diisopthiosulfate and isothiocyanate. All these models can be purchased at chemblocks.com.